Hello. Hello. Okay, sounds right. So let me share this quickly. I have it right here. Just let me share this quickly on social media. Let me share it very quickly. And one, two, three, it's done. Okay, so no more time spent doing other stuff. Now we can get ahead of ourselves and start. Let me just pause some music I have for the background. And first things first. So, as you may have noticed, I changed the camera from that way to this way because I realized that since we were going to be doing some live coding, live programming, live software development. You were, or you are supposed to see like my my terminal emulator, and it was like it wasn't showing like the full or like the full terminal if I put my camera on the other way, on the other side. So, yep, that's the thing. Okay, so I streamed last Friday, I think. So it's been like 3, 4 days since the last stream. Um, I'm gonna be completely sincere. I don't recall exactly where we are. I recall that we were doing some exploration on LangChain, on some concepts regarding LLMs and how LLMs can be hosted locally. Give me a sec. My hair is bothering me. Okay, so I just cut it off. Okay, so as I was saying, what I can recall is that we were doing our last session, we were doing like some research on how like we can host LLM models locally. I figured out, or I didn't figure out, but I discovered that there are different ways or different formats to store like the things that enclose an LLM model. Okay, now that I remember, my last research thing that I was doing, I was trying to figure out like what was the things like enclosed in the format that an LLM model has. For example, you have the, let's call it GPT.4, GPT4.bin. So what I was trying to figure out is what was the contents of that bin file, or what binary data was formatted in that file. So, yep, that was it. Yep, okay. So, anyways, anyways, what we are going to do right now, and as of now, is that we're going to continue with that research. So, let me browse through my ChatGPT history because I don't remember what I last asked about. So, okay, okay. So my last question was about, okay, so yep, like how to start like an local LLM model. Yep, gave me these options: Llama CPP, Transformers, and Olama. I recall that there's like an Olama integration for LangChain, so that was probably our go-to solution for local LLM models. Yep, there's this Olama integration. Okay, makes sense. Okay. The other thing was to use transformers, which was Hugging GPT or Huggins GPT way or loader, for LLM models. Hugging Face, not Hugging GPT. Hugging GPT was the Jarvis like agent created with Hugging um, GPT models that we talked about in the last stream or the previous one. Okay, so yes, you can use that transformers loader, which was like the runtime to load local LLM models. Okay, like so you can think of it as, let's say, if you're familiar with the Java models or bin or gguf files are like dot what was it? Dot class files that you can load into like JDK like the runtime. So the JDK runtime would be analogous to or these loaders, these LLM model loaders are analogous to a JDK, and the .class files are analogous to the .bin or gguf files that are stored or that store like all these metrics that an LLM model encloses, which is what I think that I don't know yet. Like what does that binary enclose? Okay, okay. So I asked about available formats and model runtimes and how they work. Okay, so I remember, yes, there are different formats. I remember there are some formats produced with PyTorch, others with for TensorFlows. There are also there's okay, so and if I recall correctly, these libraries or these LLM model training libraries produce like operating system dependent binaries or files. So you need a way to optimize it and translate it to a format or an architecture that your operating system can support. So, yep. Okay, yes. DGUF. Okay, okay. I don't know why, but I've heard that for local LM models and open source models, instead of using GPT, lots of people use Llama and Meta's models, so that may be the way to go, but I'm not sure yet. Okay, so you had this GGUF model, these quantified llama style models. Okay, we already read about this. We already read about model runtimes. Yep, that you had like these uh, optimized versions of the models. How runtime works under the hood, so there's an inference cycle, you get input, you tokenize, you convert text to tokens, you can tokenize your model, okay. You forward pass, feed tokens to our layers, applies attention, MLPs, etc. Okay. 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 So they're okay. Yep. So for example, we have PT, which I guess are PyTorch and Bean models. Okay. Which is like the full version of the model. And you run it on VLLM or transformers, which is the Hugging Face loader. You have GGUF, which are quantized llama style, which is use llama CPP or llama. Okay. Then you have ONNX, which are exported for performance inference. So performance-based models, I guess we're using ONNX, and you use that tensor or ONNX runtime. Okay. Uh, then I don't know what I asked GPT here because it produced another output and there's no prompt to the right. So I guess I asked about questions. So it says a great question. Let's break these down. Uh, So it says, let's break this down into a super clear for beginner friendly way. When we say large language model like GPT or Llama is stored in disk, we're usually talking about three major components. Okay, so yeah, that's what I wanted to know, because what does storing what does storing like a model in a file means, because that's like a very abstract or vague way to explain it. So it says, think of it as a blueprint, like a class, I'm guessing, or the layout of the model, like the design of a neural network. It defines how many layers the model has. Okay, so I'm assuming that my viewers know at least the minimum or the basics of neural networks. They do have like they're composed like from layers, right? Multiple layers usually. Okay, so it defines how many layers the model has, how big each layer is, how tokens are embedded into vectors, what kind of operation happens, like attention, forward, and normalization. Now, I'm gonna be completely sincere. I'm getting into new fields here because I do know, as I mentioned in our previous streams, AI development. I've done AI development as in using LLMs and AIs and like third-party services, third-party services that provide like LLM inference or Gen AI capabilities, but developing like the actual neural networks or like the actual development, the research or programming or of the models itself, that's unknown fields to me. So right now I'm reading about uh, embeddings, which I've heard of, or neural networks, which I know a few things about, like uh, a very abstract or vague concept about it. So yes, I guess we will need to get into it or not, because we're using already created LM models. But if we need to create some actual like LM models for ourselves, for MINA, we will need to create um, a model and use PyTorch or TensorFlow to create our models. But that's not the case. So, yep, let's continue. So it says the model architecture, okay, which defines like a blueprint. Okay, yes. How many layers, how big the layers are, how many tokens, how tokens are embedded. Stored files like config.json, Hugging Face files, part, okay. Okay, so stored in files like config.json. The model architecture, what? The model architecture is stored in config.json files, Hugging Face, okay. In part of a GUF or ONNX file in other runtimes. In C++ tools like Llama or CPP, this often is baked into a model file itself. Example, this tells the runtime how to build a brain, because I guess you could embed like the binary, some binary data, and then the loader, because it's like a binary protocol, can parse away like the binary. I mean, our loaders basically like binary, like like a binary protocol reader, like not like a binary protocol reader, but like a parser or some kind of what? Not sure. Okay. Anyways, um, okay. So it has a model architecture. It has a model weights, which I don't know what are weights. These are the learned values or numbers that the model adjusts during training. You can think of them like knowledge for model stores. Okay, so weights, it's knowledge. Okay, and you make weights when you modify weights when training your model. Okay, Every connection in a neural network is a weight, usually floating point numbers. Yep, okay. They decide what the model has learned, how it knows grammar, facts, reasoning, etc. etc. There can be billions of weights in large models. Okay. So like model weights refer to the like the path, like neural paths, maybe. Like yes, like the neural paths, like the knowledge. It defines knowledge, I guess. It's okay. So model weights is stored in PyTorch model. In binary files. Okay, in safe tensors for models, in GGF for llama.cpp, and in ONNX. Okay, so what I'm reading, or okay, so is if I recall correctly, you had like the first version of the models which are output from PyTorch or TensorFlow. Uh, s- okay, so these are like okay, so okay, yes. Okay, yes. And then you have GUF and ONNX, which what I can infer from now is that they compress like several files or several or the bunch, the parts that like the whole parts of what a model enclosed in a single file. Like they have like the model architecture, the model weights, and the tokenizer, I guess, in a single file. So that's the thing. So okay, so the weights. Okay, didn't read this. Okay, they are massive arrays of numbers. These make up the most disk space. Okay, then you have like a tokenizer and configuration files. How to talk to the model. So I guess okay, so there are three things here that are being described. Okay, three major okay, so we were talking about okay, so these three things we're talking about components of a large language model. You have model weights, you have like the model architecture, and the tokenizer and configuration files. Okay, which is like the way you talk to a model. It says before text can go into a model, it has to be tokenized. Yes, because they can't read like plain text. You have to make it into embeddings or like not embeddings. I think I'm using the wrong vocabulary because of my ignorance. So let's continue reading. Okay, so before text can go into a model, it has to be tokenized, broken into small chunks like words or subwords. Yes, just like a tokenizer when you're building like a compiler or transpiler or whatever. So I guess it's the same idea of a tokenizer, except that like the tokenizer of a parser or a compiler, whatever. You divide it, you divide or you parse, you get words. Here you get like chunks. Okay. You also need a tokenizer config, which is how to split text, which tokens are special. You have a vocabulary file. You have other settings like whether to lowercase text, token ID mappings, special tokens. Okay. Okay, in these settings are stored in files like tokenizer config, vocabulary.json, merges.txt, and special tokens.map text. Okay, so visual summary. Or for formats like GUF, all of the above. Okay, so for example, okay, okay, so yes, this is what I was alluding to earlier. That for example, like the first draft of an LLM model or of a model is composed of various files, but when optimized, you can transform it into a GGUF or a GOOF. I'm gonna call it GOOF because it's easier. A GOOF or an on or an UNX file, and that's like a optimized version of it. Okay, so you have config.json for the architecture, PyTorch model for the weights, which you get when. when you train your model, which basically the base are an array of numbers, of floating numbers. You have tokenizerConfig to configure the tokenizer, vocabulary for vocabulary, and merges to txt for I don't know what for. But again, we're not developing like Python or TensorFlow models from scratch. So let's not get ahead of ourselves and start like learning like the deep details of these technologies. If if we need to, we'll do it, but not now. So in simple terms, you have like the architecture, which is like the brain or layout. You have the weights, which is the brain's memory or knowledge, and then you have the tokenizer, which is like the interpreter. If you want to see a real example, I can show you the file structure of a real lemma or Mistral model and what each file does. Or we could try loading a tiny model step by step with code, so you can see how the weights and architecture is used. Okay, so yeah, I already know how these work. Now let me ask this GPT how to load a local model in LangChain. Okay, so I guess I could use some kind of Hugging Face interface, LangChain or Llama CPP. So it says, great question. Here's how you can load a local model in LangChain step by step, and you can do it offline. Assuming the model can and dependencies are already in your machine. Okay, so I need to have Python, LangChain, a local model, and a runtime inference engine. Okay, like Llama, text generation, web UI, or transformers. Okay, so my first option is to load model via Hugging Face transformers. This is the most launching native way to load models locally. Really? Okay. Make sure you have your model locally. So I can directly download my model and reference it from Python code. Okay, for example, download a model from Hugging Face and point to the folder path. Okay, so for example, I get local path, then I get my tokenizer, auto tokenizer, which comes from transformers, from pre-trained model path. Okay, so I would need to learn how to use transformers. Then I get the model from auto model causa for casual LM from pre-trained. Then I set up a pipeline, which is this. Okay, I'm already getting into the inner workings of pipeline. Where does pipeline come from? From transformers. So I get transformers, tokenizer, max new tokens, wrap it with LangChain, LLM, Hugging Face, pipeline. Okay. Okay, then I have load via Llama CPP. I could load GGUF models if you're using Llama CPP or a GGUF model. I can install LangChain plus Llama CPP, because Llama CPP was like the C++ version optimized of Llama. You also need to compile Llama CPP with GPU or CPU support. Okay, I could load the model. So LangChain. Okay, so Llama CPP is like a more integrate, like like a more like an easy way to create an LLM model. Okay, cause it's already integrated But again, I have these configurations and I don't know what they mean. I will have to do some research there. Okay, so this method is full. Okay, then you have option 3 to load it via text generation web UI API. If you're in a local server like text generation web UI, you can use LangChain's LangChain's API wrapper. Mm, would you like help you can mouse in unblock? Okay. Okay, let me check how my Python looks like because I remember I haven't written nothing. Yep, I have written absolutely nothing. Let me just open a new okay, let me just open a new of this and just let me rename it to environment. I remember we learned about Python environments. If I don't remember correctly, you simply my simply source my binary activate. Okay, so here for example I already have my environment. Again, okay, so I already know how to set up in theory, like in theory how to set up things. Okay, so let's jump all the way back to the last stream and remember we were doing some tutorials. Build chat models. Okay, I think we were here. Yes, after doing this tutorial, you'll have a level. Okay, so I remember. Yes, we did set up LangChain. We didn't set up Langsmith because that was a cloud-based like service, and we didn't want to use cloud-based services. Okay, okay. So yeah, we don't need this. Then we can use this thing using language models. It says first. Okay, so we can use different models. Okay, chat models are language models that use a sequence of messages as inputs and return messages as outputs, as opposed to plain text models. Okay, these are generally newer models. If you like to write your own chat model, this is how to. If you like to contribute to and integrate, okay. So this will, okay, so how to write the chat model class? I guess that would be for writing like an adapter or an integration. In the case there isn't any integration for LangChain for a custom model. Okay, okay, okay. So for example, it says that okay, if not, okay, you set environment variables here. You need one here and you invoke. Okay, while all LangChain classes support and indicate advanced features, you may have to open or provide a specific documentation to learn which hosted models or backends support this feature. Okay, so we have tool calling. Okay, so interesting here. Okay, so chat NVIDIA. Okay, so there are several uh, models that I could use. Uh, Okay, so I have Anthropic, which was the company that has Claude. So it supports tool calling, it supports structured outputs, JSON mode. Oh wow, it supports JSON mode. Okay, it supports local and multimodal. Okay, so Anthropic it's multimodal. Is there any open source framework that is multimodal? That what? Okay, okay, that's a big problem. That is a big problem. Um, okay, so I have all these models here. So I have okay, GPT, XAI, chat models. Okay, so there are various models. There are quite some few models. Again, most of these I've never heard of. Some of them I've heard a bit, and maybe one or two of them I've actually used as a, let's say, AI developer, not directly, but like for calling them from APIs and other third-party services. Again, what I'm gonna do is that I'm gonna try to figure out which uh, which should we use, cause okay, but reading this table here, I think we would want some multimodal models, because text only models are simple to or no, they aren't simple, but they aren't enough to our needs. I mean, in the future, you may need like MINA to view some like real life video or access some cameras or images or whatever. So what we're gonna do right now is that I was thinking, I just thought about it actually. I think if I try to implement like multimodals from the start, I can bottleneck myself, or I can, let's say, take like the a bad route, because this is a first draft, a POC, an MVP. So maybe we shouldn't focus on having the full-blown features of the final product. Okay, so for example, let's continue reading this to discover how this works. Okay, so this guy calls, for example, let me configure this to call llama. Fireworks, llama. Okay, none of these options offer llama. I'm guessing because it's like offering more like third party or AI or like models hosted on the internet. Okay, so yep. Let's produce the model directly. Chat models are instances of LangChain runnables. Okay, so I'm guessing a runnable, some kind of interface. Yep, just what I guess. Which means they expose a standard interface for interacting with them. I like interfaces. I really like working with interfaces. I do like working with interfaces and I prefer them over abstract classes because I don't know, interfaces are just nice. I mean, there's no this polymorphism or yeah, like this inheritance issue you always get when declaring like an abstract class like like what would you like an abstract class? I mean, interfaces are the way to go most of the time. Yes, like I'm not the biggest fan of inheritance, but it has some use cases. Anyways, so okay, you have like a chat model, which is something you get that like implements like a runnable, which is an interface that expose um, standard functions to call them. To simply call the model, we can pass a list. We can pass in a list of messages to the invoke method. So I guess so you have runnable.invoke. I guess that's a method. So you get the model from init chat model. Okay. Uh, then you can okay. So there's human and system messages. Okay, so I'm familiar with this type of messages, like the type of messages you get when talking to an underlying AI model, because I've worked with Azure OpenAI models, and you define like system messages. You also have user messages, and I think there's another kind of messages. So system messages are like instructions for the AI, and human messages is like the actual prompt that the AI that you're supposed to feed the AI. So yeah, makes sense. Okay, so you call this invoke and you get ciao, which is, I don't know, Italian. I already knew that. Okay, additional keywords, refusal, none, response metadata, token usage. Okay, so also again, the runnable instance returns like a full result of the message of the LLM response, not only like the plain text response. So you get token metrics, token usage. You get the type of tokens used, audio tokens, reasoning tokens, rejected prediction tokens, okay, cache tokens, model name, system fingerprint, finished reason. Okay, you also get your finished reason, which is something I've heard, or not heard, but worked with when using Azure OpenAI ChatGPT models. And you get run, metadata, output tokens. Okay, so you get metrics about the tokens and the prompt itself and the content. Okay, so that's an AI message. Okay, so if we've enabled Langsmith, we can see that this run is logged to Langsmith. Okay, so again, not using Langsmith because a third-party cloud service, and that's not convenient or not. It doesn't fit Mina's needs. So you get note that chat models receive messages objects. Okay, message object as input and generate message objects as output. Okay, yep. Okay, yes, makes sense. In addition to text content, message objects convey conversational roles and hold important data such as tool calls and token usage counts. Okay. Okay, LangChain also supports chat model inputs via strings or OpenAI format. The following are equivalent. Uh, Human message, hello. Okay, I guess it would be we would have more of a granular control if we specify like the type of message directly. But there could be any situations. There could be situations in which using this OpenAI format are more convenient than explicitly stating like the type of message being inputted. Inputted, I guess, that being the type of message being used. Okay, you can also streaming. You can also enable streaming because chat models are runnables. They expose a standard interface that includes async and streaming models of invocation. Okay, so this allows us to stream individual tokens from a chat model. Okay, so I can for token in model.stream. Okay, so I can like as if it was HTTP 3.0, like like get data while still retrieve data. So yeah, I guess this is okay. It's okay. So this thing actually is very useful because when we're going to be building like the STT or TTS layer, and let's say you get or you produce some kind of you prompt the MINA as agent for some data, and you wanna hear some data back or hear some output back in the form of speech. You would probably want to stream like the response while you're getting it instead of waiting till you have the full response. Because, you know, what if the response is very large? What if the response takes 30 seconds? Because I just asked about how planes work. You would want to stream that because you don't want to wait 40 seconds to get your response. You probably want to get your response as soon as possible. Okay, so makes sense. Then you have prompt templates. Right now we're using lists of messages directly into the language model. Where does this list of messages come from? Usually it is constructed from a combination of user input and application logic. This application logic usually takes the raw user input and transform it into a list of messages ready to pass to the language model. Common transformations including adding a system message or formatting a template with the user input. Yep, yep, okay, yep. Prompt templates are a concept in LangChain designed to assist with this transformation. Okay, so it's like a way to parse strings. Simple, easy to understand. Okay, so they take in raw user input and return data. A prompt that is ready to pass into a language model. So I have like a system template, and so I guess I enclose like my dynamic values in curly braces. Prompt template, chat prompt template from messages. You get system template, and user text. Okay, okay, yes. Uh, Syntax is might not be that clear. Okay, so okay, yes, I haven't used Python in some while. So I just noticed that these are tuples. So again, you call this from messages with an array of two tuples. The first tuple has system and template. Then you have user and the text. Okay, so note that chat prompt template supports multiple message roles in a single template. We format the language parameter into the system message. Okay, and the user text into user message. Okay, the input to this prompt template is in a dictionary. You can play around with this template by itself to see what it does by itself. Okay, so I can get a prompt from the template by using invoke. And passing, so usually in invoke pass the messages. Okay, so invoke is the runnable function, the function of a runnable. Okay, so instead of passing like the messages itself, I pass a map between like the like the placeholder, the value configured in the template. So for example, then I get chat prompt value, messages, system message, content translate the following English into Italian, additional keywords. Okay, okay. Human message, hi, okay, okay, okay. Okay, when I invoke this, I don't, okay, I'm not calling any LLM. Okay, so it's not a runnable. Oh, it might be a runnable, but it's not that type of runnable that calls an LLM. Okay, so we can see what they returns a chat prompt value that consists of two messages. If we want to access the message directly, we do prompt to into messages, and we get these two messages, A messages. Finally, we can invoke a chat model on the formatted prompt response. You get a response from model.invoke. Okay, yes, pretty pretty straightforward. Okay. In conclusion, That's okay. That's it. This is all you've learned how to create your first simple application. But okay. How to get observability? Okay, so I don't think if we need. I don't know if we need observability or whatever Langsmith provides as a service. I guess we'll know whenever we need it, but not now. Okay, so you have conceptual guides. Okay, so you have this conceptual guide. Okay, so this conceptual guide. Okay, now I'm right now in tutorials. So I have this runnable interface, which I'm gonna read skim quickly. You have it's the foundation of working with LangChain components. It's implemented across many of them, as we just noticed again, because you have, I guess, or I assumed that the prompt template was a runnable too, because you had like the invoke method. So I guess LLM models are runnables, templates, prompt templates are runnables. Uh, Not gonna read this. I guess we'll figure out how runnables work whenever we finish reading this or this documentation. Okay, so I was reading about this. Again, you have semantic search. Build a semantic search engine over a PDF with document loader embedding. Okay, so these quick tutorials, I'm gonna skim them like really quickly, just to understand like how they work under the hood, or like not how they work under the hood, but just to understand like what LangChain is capable of. And once I understand like what LangChain is capable of, or what features it provide, or whatever, we can jump directly and straight into actually like using the library, and I don't know, like using the library and experimenting with it, setting up a local LLM model and trying to figure out like if it's what we need, because new technology, we need to know how it works before using it. Semantic search engine. Okay, so semantic search. I built a RAG system, or a RAG driven application using Azure AI services. I know what a semantic search engine kind of does. Lets you like semantically search over a bunch of index records and get some data, which is an interesting tutorial because it's going to show us how RAG is okay, or how RAG can be achieved with LangChain. So interesting. Okay, so it says this tutorial will familiarize you with LangChain's document loader, embedding, and vector store abstractions. Okay, I think I'm really liking the idea of using this LangChain, because from what I know, or from what I've read offline and online on stream, there are various tools to achieve like common AI features like embeddings, vector stores, LLMs, drag. But what I'm seeing here is that LangChain provides some kind of unified interface to access different other systems, but within a same unique API, or within a consistent API or interface, let's say. So yeah, so I like abstractions. I like these abstractions. What I what I don't like mostly, again, it might come as okay, doesn't matter how might it come. But what I still don't like is that I have to use Python. I would love to use Go right now and write everything in Go. But again, probably not the right tool for the job. Uh, Doing a first draft POC MVP, so need to work fast. Um, Most of the AI's community and the AI community in general bases most of the research and projects in Python. So, understandable, yes. Desirable, not 100%. But yeah. Okay, so these abstractions are designed to support retrieval of data from vector databases and other sources. Okay, so as far as I'm concerned, vectors are like um, a format or a version of data, but in a way that an AI can understand it. Now that's a really vague explanation for it. So let us read a little bit more and ask GPT if we have any trouble understanding issue like vocabulary and concepts, because as I said earlier, I'm delving to new technologies, at least for me, or because although familiar with AI and building AI-driven applications, never built the underlying AI itself. So that's a thing. It says these abstractions are designed to support retrieval of data from vector databases and other sources. For integration with LLM workflows, they are important for applications that fetch data to be reasoned over as part of a model inference. Okay, they are important for applications that fetch data to be reasoned over as part of model inference, as in the case of RAG. Okay, here we will build a search engine over a PDF document. This will allow us to retrieve passages in the PDF that are similar to an input query. Okay, this guide focuses on retrieval of text data. We'll cover the following concepts, documents and document loaders, text splitters, embeddings, and vector source and retrievers. Okay, so sounds like really fun and all-in-one journey to understanding or getting to know more about different LangChain features. So let's give this a quick skim. Um, or not skim. I think I'm reading it. I'm not skimming. So okay, so installation you install it by LangChain community, which as far as I remember has integrations for other has like this package has integrations that aren't that don't have a package for themselves. So yeah, you have Langsmith. Okay, again setting up Langsmith. We're not interested in that. Okay, so it says LangChain implements a document abstraction. Document sounds a lot like what OpenAI not, but Azure AI search indexes have, like the documents that I don't know if you guys are familiar with it, but Azure AI search, it's like a service provided by the Azure AI search or like Azure AI like family of services, and it provides like a way to store like records. I don't even know how to explain it. It's like let's call it okay. So Azure AI Search, it's like the service that provides a way to create indexable data that an LLM model can use. Now, each of these indexable uh, data parts are called records, and records can have vectors, and each of these records are called actually documents. So that's why I just related this document thing, which is what I'm guessing that this kind of document abstraction from LangChain is. So it says LangChain implements a document abstraction which is intended to represent a unit of text and associated metadata. It has three attributes. Okay, an ID which is let's read it top to bottom. Page content which is a string representing the content. A metadata which is a dict containing arbitrary metadata, and ID which is an optional string identifier for the document. Okay, so we have content, metadata, and ID. Pretty straightforward and simple. Then you have the metadata attribute can capture information about the source of the document. Okay, its relationship to other documents and other information. Note that individual document object often represents a chunk of a larger document. Yeah, like like that each document represents like a chunk of an actual like file, not a document. I think the wording is a bit confusing, like using document and for representing a chunk of a big like physical document. So my camera just fell. Let me fix it. Uh, got nervous. Uh, okay, so it says we can generate sample documents when desired. Again, documents being this abstraction. So yeah, um, LangChain's ecosystem implements document loaders that integrate with hundreds of common sources. This makes it easy to incorporate data from these sources into your AI application. Yeah, it makes sense because okay, let me read this first before making assumptions because they give me lots of data here and my brain is cycling us through all these ideas. But I don't want to get ahead of myself again. So, loading documents. Let's load a PDF into a sequence of document objects, again, chunks. Okay, it says there's a simple PDF in the LangChain repo, a 10K filling for Nike from 2023. We can consult the LangChain documentation for the available PDF document loaders. Okay, let's select the Pi PDF loader, which is fairly lightweight. Okay, so again, you get the file path and you simply load it via the file path, and then you get loader.load. And I'm guessing that when you call loader.load, you get like the document object itself or an array of documents, because this guy or this tutorial just named the variable docs. So yep. Then it prints the len of docs. So yes, okay, so it accessed like the len property of docs. So okay, so that's a big problem I have, and this is like a really clear example because right now since we're reading Python code, right? In Python it's typeless, so there's no like it's not typeless because you have like types at the end of the day, but there's no like statically typed. It's not statically typed, so you can't view explicitly like what type is the type of a variable. So for example, I just have to infer from from the code itself what type of data or what form in memory or what let's say what yes what form in memory does the doc variable reference. But again, if these were a more statically typed language, let's say Java, or let's say Go, which I really like, or let's say even TypeScript, which is not a language but some kind of LSP, or let's say, well, not LSP, but anyways, I'm not gonna get into a TypeScript debate here. But if this were a statically typed language, it would be really easy to infer what type of data does the docs variable reference. But again, uh, Python is an untyped language, loosely typed language. So again, it's all about trade-offs, but I wouldn't make this trade-off. Anyway, I'm seeing that docs is an array of documents because you get the length from it. Okay, so PyPDF loads one document object per PDF page for which we can easily access. Okay, so interestingly enough, okay, so this is very interesting. So you get an arbitrary value of pages per document per chunk, the string content of the page. Metadata constraining, it says Python loads the document object per PDF page. For each, we can easily access the string content of the page. Yes, you get the page content and metadata containing the file and page number, and optionally you get the ID because it was an optional field of this document abstraction, which I'm guessing the document abstraction is some kind of interface. Although I think Python doesn't have explicit interfaces. What I think it has, I don't know if they have interfaces. Not sure. I've never had to develop an a, a program or software that is uh, enough complicated in Python to have interfaces. Because again, as a Python user, I'm only going to be using Python for little scripts. But I guess right now we're doing some kind of change because it seems that we're going to be building lots of Python code or writing lots of Python code. So yeah, okay. Okay, so what I'm seeing here again, um, okay, again, so what I mentioned before that about like this comparison of document loaders and the Azure AI search index service, it makes or they seem somehow related. Okay, I also see how this relates or the similarity between Azure AI search and this document loading because I remember that the way I've used Azure AI search is to load or to get information from files to extract data from files, and I remember that the way you extract data from files is by first well, in that service, by first parsing each like blob document or like physical file into a markdown, and then from markdown you get like the chunks of data, like the records or like the document itself. So it makes some sense having like a different document loader type to load different types of files. For example, because not all files are equally created, but for example, what if you have like a new format of files? What if you want to feed a rack system? What if you want to what if you want to feed a rack system like data coming from a binary format, from a custom binary format? Let's say I am a like a brilliant guy and I develop my own binary format. Let's just say that. I'm saying that, but let's just say that. What if I want to feed like the binary, like the data encoded in this binary protocol to a rack system, to an LLM model? It would make sense. It would really make sense. Okay, so it would make sense. It would make sense because I could because no one except like this document loader and myself on whatever parsers I have developed in the past could use the information encoded in the binary file. So yeah, makes sense. It makes a lot of sense. It makes a lot of sense, and it doesn't always only make a lot of sense, but it sounds really useful. Okay, so again, the document loader in this case, this document loader um, loads data. It doesn't load data. It parses like the PDF document. It returns like an array of documents, and in the array of documents, uh, each document is the one page of the PDF which has information. So yeah, and then you get like the page content, which is the string version of the document, and then you have like the metadata docs. No, not the metadata, but like the metadata map, which is like a map of arbitrary metadata field by the document loader, so makes sense. Okay, so again, let's see what about splitting. Okay, so for both information retrieval and downstream question answering purposes, a page may be too coarse. I think I just approached a language barrier. What does this word mean? Sorry, guys. I might need to look this up, because never heard of these words. Coarse,
Course.
coarse, like thick, coarse and thick. Okay, so upskilled my English levels, I guess, because learn new word, coarse, which means thick or big. Okay, so a page may be too coarse. Um, a representation. Our goal in the end will be to retrieve document objects that answer an input query, and further splitting our PDF will ensure that the meanings of relevant portions of the document are not wasted by the surrounding text. Okay, so you have like a very coarse or thick the like document. You can split it into like mini documents. That's what I'm reading. I guess it says we can use text splitters for this purpose. Here we will use text splitters or a simple text splitter that partitions based on characters, like partitions. I don't know how to read. Sorry, I got distracted while reading something on my right monitor. Okay, so we can use text splitters for this purpose. Here we will use a simple text splitter that partitions based on characters. We will split our documents into little chunks, well, not little chunks, but into chunks of 1000 characters with 200 characters of overlap between chunks. Okay, the overlap helps to mitigate the possibility of separating a statement from important context related to it. We use a recursive character text splitter, which will recursively split the document using common separators like new lines until each chunk is the appropriate size. Okay, this is a recommended text splitter for generic text use cases. So we said um, at start index to true, so that the character index where each split document starts within the initial document is preserved as metadata attribute. Okay, so this will I know. So what I'm reading is that it will add a metadata. Uh, these are implementation details. Not worried about this right now. Uh, okay. Okay. So key takeaways. You use a splitter to get splits, which are like chunks of the already chunked document. So you get text splitter, which is from okay, chunk size. Okay, so when would I need to use a text splitter versus not using a text splitter? I guess when a page is big enough or when a page is pretty big, then you would like to split text. But how can I determine that? How can I measure that? If I can't measure that, should probably do it always. Um, yeah. So for example, here, I had my documents. Okay, and these documents were splitting into my 100 documents of large text was splitting into splits, I guess, into five into plus 500 splits. So okay, so yeah, it makes sense. So what I'm saying is that to build like some kind of RAG system from scratch. You need to have like this pipeline, and it makes sense. So you first load your documents, or you need to extract like data from your documents. You need to split it into chunkable and let's say like more searchable versions. And now it says something about embeddings, which I'm curious to read about because this embeddings word is a word that I've heard quite some time, especially when it comes to vectors and like images when fitting them like to AI systems. So this is very interesting. So it says, vector search is a common way to store and search over structured data, such as unstructured text. In this case, we have unstructured text. Okay, so the idea is to store numeric vectors that are associated with the text. Okay, yes, I've seen it. I've seen vectors in Azure AI search, and I've seen them as numbers, as arrays of numbers. And now that I recall, some communities or some tech spaces use vectors and dynamic arrays interchangeably. I think, for example, C++ uses vectors like vector lists, and that I've never tackled with C++ myself. But that's the thing I know because I've written plenty of C. Well, not plenty of C, but some I've written my fair amount of C code, and I've had to interact with some C++ code base, not code base, but code files. And yeah, I've seen it that they use like some kind of vector thing to store like contiguous like amounts, not contiguous amounts of memory, but related addresses of memory. So yep, the idea is to store numeric vectors that are associated with the text. Okay, given a query, we can embed it as a vector of the same dimension and use vectors. Okay, so yes, now here's where I'm getting completely lost. Let me start again. So you have embeddings. Okay, so vector search is a common way to store and search over unstructured data. Okay, so vector search, you search over vectors. What are vectors? Okay, the idea is to store numeric vectors that are associated with the text. Given a query, we can embed it as a vector of the same dimension and use vector similarity metrics such as cosine similarity to identify related text. LangChain supports embeddings from dozens of providers. These models specify how text should be converted into numeric vectors. Let's select model. Uh, Yep, I might need to do some research on water embeddings and vector search and all of this. So what I'm gonna do right now is that I'm gonna go to a bathroom real quick. Not gonna take much time. I'm gonna turn off my camera before I go, but I'm gonna be right back. So just give me a sec, and then we can continue our research because I really want to understand what are embeddings and vector stores like on a in-depth level. So see you in a couple seconds, probably less than 1 minute. Nope. Okay, now. back. I'm back and I'm going to turn my camera on. Oh my god. I'm back now. I'm back with my camera and ready to continue our research. So let us continue our research. Okay, so I just went to the restroom really quickly and we're back. So what I was saying is that I was just about to read about embeddings and vector stores, and like this whole embedding system that RAG systems usually have, or this kind of yes, this RAG systems usually have. Because I was going to read about it, but then I found myself lost in vocabulary and concepts that I didn't understand. So we're gonna give it like a rest for some minutes to this quick skim over this LangChain documentation, and we're gonna do some research on those topics that I just mentioned. So, as my first source of research, let me just use GPT because it's the is not the easiest, but the and not and definitely not the most reliable, but the quickest way to get information. Uh, and now that I mentioned that, I think I haven't mentioned one of the big purposes or the main purposes of MINA, which is related to what I'm about to do. So I find it annoying have to having to having to search for things uh, like manually, like doing research. Not annoying. You should not. Okay, not when doing research, but I find it annoying when I want to know something and I know that I have it somewhere or I know that it exists, but I don't. I need to like do go through my computer and find it. That's why, for example, I have this automation or let's say like this script in my CLI interface to quickly uh, find a file and let's say write it. For example, I can press Ctrl W on my CLI or my shell and I can type whatever document and I will easily jump to a document in to a document like search. So that's like a big thing. Like that's okay. So what I'm trying to say here is that I don't like to take the time to look for things where I already know that the things exist. I think that's like a waste of time. So this automation I have in my shell script is an example of it. And where I'm trying to get to is that I want to make MINA a unified resource or like a unified like a unified source for finding resources or for accessing the internet or your computer or whatever. So the same way that I'm using here ChatGPT to do some research and explore, or for example, to do some research and ask about whatever concepts I'm about to ask. Uh, in the same way, I plan or I'm designing MINA or I have in mind that MINA is used to access the internet or get information uh, easily, like simply prompting it via speech, via voice, via text, via whatever. So yeah, that's like the idea. So I think I didn't mention that before. I think I should highlight that probably more often when promoting or when talking about MINA. But yes, that's a thing. Um, anyways, I was gonna ask about embeddings, vector stores, uh, and that's it. So yeah, uh, let me give it some context first. Hey, I was reading about LangChain and RAG systems, and I came up with the following concepts. Following concepts. Let me list vectors, vector stores, embeddings. So let me just ask it to explain it. Explain what are these in the context of AIs. Okay, so okay. Wait, you're diving into super important part of how modern AI systems work, especially RAG, work under the hood. Let's break down the three concepts. Okay, so you have embeddings, vectors, and vector stores. Okay, so embeddings, okay, and the roles in the AI and RAG. So they turn text into numbers the AI can work with. Okay, so again, understandable because AI doesn't understand plain text. They understand numbers. Computers always understand numbers, only numbers. Vectors, the coordinates themselves, the numeric representation of ideas, concepts. Vector stores, a smart notebook of vectors, a fast search engine to find relevant content. Uh, okay, so the third column that explains like the role in AI and RAG is clearer. It's more clear than the analogy. I don't know why. So okay, so the analogy coordinates of a thought, like where is a thought, or turn text into. Okay, so let me just read more about it. So embeddings are means turning text into meaning in numbers. An embedding An embedding is a way of converting text in a vector of numbers, in an array of numbers that capture semantic meaning. Okay, so dog and puppy, similar ideas have closer vectors. The similar ideas are farther apart. And so the what does the farther or closer mean? Does it mean like the similarity or the how similar are the numbers? The same index in the other vector is the same, or how close is it to each other? Don't get it. I don't get it, but just a little. It says, and in AI we use pre-trained embedding models like OpenAI Ada, Sentence Transformer, or Hugging Face models to generate these embeddings. In RAG, we typically embed your documents at ingestion and the user's query at runtime. Okay, vectors. What embeddings produce? Okay, so a vector is a way. Okay, so an embedding is a way of converting text into a vector of numbers. So it's like a function. Let's say it's not like a thing by itself, or is it? Okay, so vectors. What embeddings produce? A vector is just a list of numbers. Okay, so a vector is a list of numbers. When we say vector, in this context, we mean a list of floats. Yeah, produced list of floats produced by an embedding model lives in multidimensional space. So technically, embeddings is the process. So I don't embed, I do embeddings. Okay, so I'm doing some embeddings, and the process is vectors. Okay, so the output are vectors. Okay, the output is vectors. Okay, so then you have vector stores, which is a smart search engine for meaning. Okay, so a vector store is a special database. Again, beta database is a really broad concept. Can be because what is a database? A base of data, collection of records, associated SQL, no SQL, uh, vague abstract concept. Again, it says a vector store. is a special database that lets you search vectors by similarity, not exact matches. So, okay, so vectors are have similarity. How do they have similarity? Okay, I don't know how do we have similarity. Okay, so vector source is a special database that lets you search vectors by similarity, not exact matches. Instead of looking for exact words, it finds vectors that are close to the query vector. So for example, if I have a query vector 1, 2, 3, and I have like a vector store which has, uh, I guess, records, or how do you call them? Like records, yes, with vectors, and I have 1, 2, 3, 4, then it will probably match. Okay, so I guess I'm getting, I'm translating like the whole process in my head, so makes sense. So, okay, so instead of looking for exact words, it finds vectors that are close to a query vector using algorithms like consign similarity or dot product. Okay, interesting. New algorithms. We can learn some new algorithms, although we might not learn them, or we might not need to learn them. Okay, interesting. Okay, fun. Okay, so if we ever make it, no, we're gonna make it. We're gonna make it. But when we make it to uh, migrating this from slow Python to a more high performance SIG code base, we might need to write our own vector store. Although there probably are some vector stores already exist, but they might not exist for SIG. Although it would be fun to write a vector store, we would learn about algorithms, about new algorithms. So yeah, I guess I mean this is a learning journey, but I don't know how much of a learning versus producing like a usable software I want it to be. Because my main idea was to be both, but we need to find the balance first. Because I could write everything from scratch, like my own implementation from scratch, but that would make slow the process of releasing like production. I was gonna say like a production build, as if this was like a web application and we're building and bundling stuff, but as if this was what I'm trying to say is that what we want to do is we want to balance like the learning and deploying stuff or taking things into production. Let's just call it that way, production, because it sounds nice writing like my own vector store or vector store A engine from scratch, but wouldn't be very wise to do it in most cases. So again, you already have popular vector stores. I've heard about them. You have Face, which is Facebook's. You can run it local and fast. You have Chroma, which is local and open source. You have others. But again, uh, vector stores. Okay, so I understand what are vector stores are collections of vectors. What are vectors are representations of words, but uh, in numeric format. They're lists of floats basically that represent word. Vector is just a list of numbers. Okay, it's produced by an embedding model. So you use a model to create embeddings and lives in multidimensional. So embeddings is a way of, okay, so you convert text into vectors. So doing embeddings or embedding is converting text into vectors of numbers to capture semantic meaning. We use pre-train in AI. We use pre-trained embedding models or to generate these embeddings. In RAG, you typically embed your documents and users' queries. Okay, so embed. Okay, makes sense. This makes a lot of sense. So how they work together in a RAG system. So let's say you ask what is quantum computing. Your documents are pre-processed. Okay, so the whole ingestion thing to make data available to a RAG system is done pre-prompt, so before the user prompt. You split into chunks, embed into vectors, and store in a vector store. Embed into vectors, and Then you ask my question. The question gets embedded into a query vector. Okay, so my question itself gets transformed into a vector. In this transformation is called an embedding. It's embedded into a query vector. Just query as a descriptor, but a vector it's just a vector, query vector, and vector don't have uh, like technical differentiations. The vector store searches for the most similar document chunks based on vector similarity, which, as we just read, are calculated with a couple interesting algorithms, which sounds exciting to implement and to learn about. Which was, okay, the algorithms, cosine or dot product. Okay, I see some potential for them. I see some potential on implementing them, but again, as I just discussed earlier, not the wisest thing, probably. Okay, so the found chunks are retrieved and passed to the LLMs. Okay, as extra context. Okay, the LLM then answers based on the retrieved documents. Okay, so okay, makes sense. This makes sense. Okay, so what it does is that this whole embeddings thing is just a way to get extra context for the LLM. Okay, so user question, query embedding, get, okay, so this is only a way to get extra context. Okay, so this whole data ingestion is to get extra context. Okay, it says embeddings translate text into vectors. Okay, so I think I understand how embeddings, vectors, and vectors work. Okay, yeah, we can jump back again to our exploration on embeddings. So I think if I read this again, I should in theory understand it better. So let me just give it a quick read again. So it says, vector search is a common way to store and search over unstructured data. Okay, the idea is to store numeric vectors that are associated to text. Okay, given a query, we can embed it as a vector. So you can embed it, that means translate it from text into a list of floats of the same dimension and use vector similarity metrics to identify related text. Okay, so basically, you can use a query to use a search engine or the vector search engine to get some extra context. But interesting, it just said something about vectors using the same dimension. So I just read from ChatGPT that there are um, that you use different models to produce embeddings. So does this mean that the okay, so what is this dimensions thing? So let me ask ChatGPT, what are dimensions in this same problem space? Okay, so let me just ask it. Okay, so it says, okay, so what are dimensions? Okay, when we say a vector is, for example, 768 dimensions, we meant it's just a list of 768 numbers. Okay, so easy. Dimensions is like the length of each vector. Okay, okay, yes. So, and a vector is a list of floating numbers produced with an embedding model. easy to understand. It says each number is a feature or a coordinate that helps describe the meaning of a word, sentence, or a document. So what I'm curious about is, for example, if I embed some vectors or if I embed some text into vectors using one model, one embedding model, could I use another? Yes, I think I must use another model to use like the produce or like the produced. um okay, so let's say I have model A. Let me draw this because I need to visualize this. So I'm gonna open GIMP because I'm not sure if I know how to even like word my question. For example, let me color this in plain white. Okay, so what I'm understanding here is that you have step one, you have plain text. Then you want to embed that into some vectors. So you do some embedding, and then you get some vectors 0, 1, and 2. You have number 2. Okay, you have vectors. Okay, so my question is, and then you use these vectors as context, right, for an LLM model. That's what I'm understanding, right? So can I use this context for another LLM model different from the one I use to embed the data? Do all models understand the same or like the same embedding format? Is there any format to embeddings? I mean, I'm transforming from text to numbers, but how is that, how is it like transformation based on what type of logic? Let me do research because need to understand this. Uh, okay, with a model that produces 360. Okay, well, okay, so we just understood this. Okay, let me just finish reading this and then we'll jump to the next question, which is what was it like, format of embeddings or the compatibility between embeddings and models? Okay, so let me read this. Two vector. A 2D vector is a point, and okay, I'm not gonna read this. Why does the number of dimensions matter? Okay, search accuracy. Higher dims can capture more nuance. Okay, so speed. The more dims means meaning dimensions. More dimension. Okay, so dimensions are in. Okay, higher dims can capture more nuance. Okay, so okay, so if I have more dimensions, I can capture like more meaning, I guess. But more dimensions also is proportional or inversely proportional to the speed of search. But what if I have like more vectors with less dimensions? Uh, okay, not sure. Then each vector takes more space. Okay, so yeah, the bigger the more the dimensions, the more the number of dimensions, the more the the space that it takes on my system, the more time they will take to search for data. So yeah, but again, then you have the more dimensions, the more expressive in meaning. So I need to find a balance. I need to calculate the trade-offs, or I don't know, do some assessment to evaluate what trade-off, what balance would fit my trade-offs. Different models produce embeddings in different lengths. Okay, so OpenAI ADA V2 uh, produces dimensions from, okay, 1536. Okay, so plus 1500 dimensions. Sentence transformers is another model for this thing called all mini LM, and Llama and other LLMs with custom heads, often 40, 96 or more. In a rack setup, when you embed your documents in queries, they're what? When I embed my documents in queries, their dimensionality must match. If you use OpenAI ADA, okay, with 1500, with plus 1500 dimensions to embed your document, you must embed your queries with the same model. Okay, so this was one of my previous questions. So if I use 1500 dimensions to embed my documents, I must embed my user queries, my prompts, with the same model or the same dimensions. If you mix 300 plus almost 400 dimensions with 1500 dimensions, similarity search won't work. So it says to use the same model for embedding and acquiring the model. But what if I use different models but with the same dimensions? We like to try generating some real embedding. So let me ask this guy again. So you said that, uh-huh, okay, he, but what, but okay, let me ask, can I use, can I use different models but same dimensions for document loading, or let's call it for document embedding and um, querying? Okay, so it says, excellent question. Okay, so but critical point. Okay, so there's okay. Uh, can you use different models but the same output dimensionality to embed documents and queries? Technically yes, but probably no. Okay, why dimensionally matching alone isn't enough? Okay, so let's say I have model A with which uses 300 dimensions to embed documents, and model B which also uses 300 plus 300 dimensions to embed queries. Even though both offer vectors of 300 plus dimensions, the numbers inside those vectors likely represent very different meanings. Okay, and structures in high dimensional space. The problem, vectors from different models won't live in the same semantic space, so similarity search breaks down. Distance becomes meaningless. Even if you use causing similarity, you're comparing apples to oranges. Okay, imagine embedding this document. Photosynthesis is the process by which green plants make food. If you use that model, and embed a question with another model like this other one, the query might not match, and even though it's semantically similar, you might ask, how do plants convert sunlight into energy? But because the models think differently, the distance between, okay, my camera fell again. Interesting how that happened again. Uh, Let me just check. Okay, now we're okay in theory. In theory, again. Okay, so what I'm getting from this GPT is that the embedding process is specific to to a model. Okay, so for example, so each embedding algorithm represents like a different dialect. Let's call it dialect. And why say model models? Embedding models are trained to map similar embeddings to nearby vectors. That only works if both query and document go through the same learned logic. Okay, the model understands both the input and the space it's mapping into. So yes, they must be the same embedding model, not just the same dimension size. Or practice for rack systems embed both documents and queries using the same model, mixing and embedding models even if dimensions match. Okay, you do this. Okay, so use model design to cross encoding or dual encoding and avoid using general purpose embeddings mismatched. Keep track of the embedding version and avoid mixing embeddings. So basically, don't mix embedding models even if the output dimensions match because they produce incompatibility vector spaces. Use the same model instance for to embed both your documents and your user queries. Only then you can only then can your semantic search actually reflect real world semantic similarity. Okay, so one help testing this in code. Uh, maybe. Okay. No, no, no. Okay, so I think I understand now how this kind of works. Makes sense. Dimensions, vector stores, embeddings, uh, vectors by themselves. This all makes sense now. So let me continue. So let us continue on our LangChain quick exploration. Okay, so it says LangChain supports embeddings from dozens of providers. These models specify how text should be converted into numeric vector. Let's select a model. So again, it's only offering cloud-based models, which we aren't going to be using because MINA is an open source project with native and local first in mind. So no APIs, no third-party services, no function calling from unknown rack systems, none of that. So we can see here how we can embed some models. So it first, okay, uses the Open API, I don't know, whatever key to get credentials, whatever. Then it imports OpenAI embeddings from LangChain OpenAPI. Okay, then you get OpenAPI. Okay, so I create an embeddings model and embed the query. Okay, so you get a couple vectors. You get the first two. Okay, you vectorized the. Okay, this makes sense. Okay, so you create an embeddings model. You embed the contents of each page content. Okay, yes, and it just checks that they both have like the same length, which they will, because they just were created with the same model. So makes a lot of sense. Okay, so so armed with a model for generating text summaries, we can next store them in a spatial data structure that supports efficient similarity search. Okay, vector stores. LangChain vector store object contain methods for adding text and document objects to a store and querying them using various similarity metrics. Okay, they are often initialized with embedding models, which determine how text data is translated to numeric vectors. Okay, yes, again, because you want to store in a vector store data from using the same embedding model because we want the same embedding like dialect and the same embedding dimensions. So LangChain includes a suite of integrations with different vector store technologies. Some vector stores are hosted by a provider, example various cloud providers, which we will not be using, and require specific credentials to use, such as Postgres, not running separate infrastructure that can be running locally or via third party. Others can run in memory for lightweight workloads. Let's select vector store. So you have various ones. You have Face, Chroma, which these two are local first. Collection, okay, then okay, you have Chroma, you have Face. And let's just see how this works with PG vector sounds as PostgreSQL. Not sure about that. I don't says this is going to be running like on a computer, like on like local computers, like on my machine, for example. I don't want to have to host like PostgreSQL on my computer just to have a vector store. I probably would probably use like SQLite if it's possible. If it's not possible, Chroma or Face sound like a really nice way and fair way to go without accessing like internet services. So let me just see how this works first. Okay, so initialize the vector store with the embeddings, which again embeddings is an interface. I'm guessing OpenAI embeddings. Yes, I'm guessing it's an interface. So you get embeddings, and then having uh, instantiated our vector store, having instantiated our vector store with the embeddings thing, and we can now index the documents. And by indexing, it refers to uh, or calling the add documents from the already created vector store variable and pass the splitted already splitting documents. Then you get IDs, which if this was a strongly typed language already I would know what IDs is, but I can infer this is an array of strings or ints that have like the an ID for each vector store. Know that most vector implementations will allow you to connect to an existing vector. Know that most vector store implementations will allow you to connect to an existing vector store, example by providing a client index name or other information. See documentation on specific integration for more detail. Vector stores. Okay, so there are various vector stores. Okay, so after reading this, like after giving this like a full, not full, but after reading this and giving it like a quick uh, read through all the documentation, we're gonna assess like what models, what retrievers, what document loaders, what embedding models, what vector stores we're gonna use before actually like building stuff. Because I think I pretty I I've understood. Okay, I think I've understood till the moment like how to use this all these APIs exposed by LangChain. They're pretty simple, pretty simple. So yeah, I can see myself just setting up like a LangChain project fully after reading these docs and assessing uh, what which of these like which of these like technologies we're gonna use. Okay, instead of creating a vector store, which I just thought, okay, so in memory, but you have in memory vector store, and you have in memory, and you have like
other, not in memory, like more persistent vector stores. I'm thinking that I'll probably use like persistent vector stores for most things, but I can see myself using in-memory vector stores for other like temporary feature things. Like what if I want to create some kind of, what if I want to create some kind of of of, like feature that requires some data protection and security, like and I want to have like some short-term memory to store some metric or some data for some kind of embedding. In that case, I would could I use like in memory vector store? Would that be an overkill? Probably. Maybe I could just store that sensitive data in memory, in like actual like memory in the Python process in this case, and just deallocate it. But again, I, I can't deallocate memory explicitly in Python, I think. So I would have to think more about that when the time comes, not now. Okay, so include for methods for querying. Okay. So once we've instant vector store that contains documents, we can query it. Vector store includes methods for querying, sync and async. Ooh, think that I have to explore, which I'll probably do offline because will probably be some kind of somewhat boring to do it online. Sync versus async, or let's say multi-process or multi-task programming in Python. Never done it. I do know how multi-task programming or multi-process programming is done, multi-thread programming, because Java and Go routines, which are awesome, by the way. Okay, you can so includes methods for querying, sync and async, by string query and by vector, with and without return similarity scores, and by similarity and maximum marginal relevance, which I guess there are algorithms to classifying results from vector queries to add similarity with query to diversity and retrieve results. The methods will generally include a list of document objects in their outputs. Okay, so I can reference like where they come from. Okay, so this yeah, this makes sense. Yeah, it makes sense. It makes sense that it returns documents, because what if I want to know like where does some data come from? Then I can simply just do something with the documents retrieved. But the documents retrieved should in that case include some kind of metadata in its metadata properties, instead of not including anything and only relying on the page content. Cause yeah, it would make sense. Okay, yeah, makes sense. Um, it says embeddings. Okay, so usage. Embeddings typically represent text as a dense vector, such that texts with similar meanings are geometrically close. This lets us retrieve relevant information just by passing in a question without knowledge of any specific key term using a document. Return documents based on similarity to a string query. How many distribution centers does Nike have in the US? And it will print the result number 0, which is a document. Okay, so results. Okay, so the vector store. If I okay, what? Okay, results vector store dot similarity search. Okay, so it's not really giving me like the full set of Gen AI output, because it's not using an LLM. It's retrieving like the top results. Okay, pay direct to customer operation yourself. Okay. Because if it would, okay, so if it had, if okay, yeah, it's not Gen AI here. Because if it was intelligent enough to give me like to answer to the question that was just asked in this sentence here, it would give me how many distribution centers. Total 369 distribution centers, instead of giving me this, which is like the page like, no, what is this? No, this is a document. This is like a document object. Yeah, makes sense. Okay, so it's pretty easy to get results sync and async. I just await stuff. Okay, return scores. Note that providers implement different scores. The score here is a different metric that varies inversively and with similarity. So I guess whenever I choose what vector store to choose, what vector store to use, I have to manipulate or do some kind of math if I ever need to with the similarity scores. And the difference between getting score and not is just calling one or another, okay, function. Then you have something called retrievers. LangChain vectors or objects do not subclass runnable. Subclass. Okay, so runnable is okay, a parent class. So we're talking about in okay, we're talking about the hierarchy of classes. So LangChain vector stores don't subclass runnable. LangChain retrievers are runnables. So it implements a standard set of methods. Examples: synchronous and asynchronous, invoke and batch operations. Although we can construct retrievers from vector stores, although we can construct retrievers from vector stores, retrievers can interface with non-vector source of data as well, such as external APIs. So what I'm getting from this is that retrievers are the way to call tools also, instead of only. Okay, so retriever is what I'm what I'm what I'm going to assume right now is that a retriever cannot only read data from RAG system, but also call data and retrieve data and get data actively using tools. So we can create a simple version of this ourselves without subclassing retriever. If we choose what method we wish to use to retrieve documents, we could create a runnable easily. Below, we will build one around similarity search method. Okay, so retriever returns a list of documents and gets okay. I don't know what does the add chain mean. Okay, it's a retriever returns that, and retriever dot batch. You can call it with okay the couple functions. Vector source implement as retriever method that will generate a retriever, especially a vector store retriever. These retrievers include specific search type and search key WArgs, keyword arguments that choose to identify what method of the underlying vector store to call and how to parameterize them. For instance, we can replicate the above with the following: vector store as retriever. Okay, retriever.batch. I don't know what is this batch method. Okay, I'm guessing that it's a way to retrieve data from how many, I don't know what. Okay, vector retriever supports such types of similarity: default MMR, maximum margin of relevance described above, and similarity score threshold. Retrievers can easily incorporate into more complex applications such as RAG, applications that combine given questions with uh, to a prompt of an LLM. To learn more about these applications, I don't know what, learn more about, okay, so I need to go to a restroom again. So I'm gonna turn off my video camera and go to a restroom very, very quickly. Okay, I'm back. So let me turn again my camera so you guys can see me, and let's continue. Cause um, where were we? We were talking. We just read about these retrievers and embeddings and all these abstractions provided by LangChain. I think I understand how LangChain works now. I um, I still want to read these couple things. I do want to read these things. Cause cause I don't know. Maybe I should do it off stream. But again, the idea of this is to you guys to view how I process things and how I learn things along the way. So uh, I will I will continue reading this because you know it's worth it. Anyways, reading the next quick tutorial. It says classify text into categories or labels using chat models with structured outputs. Structured outputs. Okay, I do have some experience delving or not delving, but working with structured outputs and LLMs. You know, there was this time some months ago or some weeks, no, some months ago actually, where I was trying to make a GPT model output a structured output. But what I wanted to do is that I wanted the LLM model to output a specific schema, a specific JSON schema, but I was very new to LLMs and using LLMs like as a from a cloud provider, from a cloud service. So I didn't end up using it that way. I ended up using LLMs in another way to reach my goal. But the method I was trying to make, or the method I was trying to use at first was to make a well, not a ChatGPT, but a GPT-4o model output a JSON schema object. It didn't do it, and I'm glad it didn't do it, because the other method that I tried, which didn't involve structured outputs, resulted better. It was easier and quicker to implement, so that's the thing. But yes, I have worked with structured outputs on LLMs. So yep. It says classify text into labels. Tagging means, okay, so this is some kind of NLP processing. So tagging means labeling document with classes such as sentiment, language, style, cover topics, political tendency, whatever. So you have this input, you have this schema. Okay, this is what I was talking about. This is JSON schema, and you have a function, and you input that into an LLM, and the LLM can function call and get some data. Okay, so this function, information extraction, extracts information from the passage and passes the schema. What? Okay. Tagging has a few components. It says function. Okay. Tagging means labeling a document with classes such as labeling a document. Are we still talking about RAG and documents from like the document abstraction that we just read about? Okay, so tagging means labeling a document with classes. Okay, and has a few components. A function, like extraction in this case. Tagging uses functions to specify how the model should tag a document. Uses a function like this one, how to tag a document. Okay, and schema defines how we want to tag the document. Okay, so a quick start with OpenAI. So it initializes the chat model, which we already read how to. Let's specify a Pydantic model with a few properties on their expected type in our schema. So, okay, you have this prompt template, you have this some kind of classification class, which is some kind of new. It takes a base model, which comes from Pydantic, which I've never used. You get sentiment, aggressiveness, and language. Sentiment is a string, which field, and this description, aggressiveness, it's an int with the field, and that and language is a string that okay. Okay, interesting. So this Pydantic kind of library seems to define like some kind of schema for classes or for objects. Okay, so then chat OpenAI Tapir 0 model with structured output classification. Okay, so you get this input, you get tagging prompt that invoke. Okay, this is really okay. So this second line basically fills the template. This runnable fills the template. So tagging prompt dot invoked and it passes this input. So extract the desired information from the following passage. Only extract the properties mentioned in the classification function, and it passes the classification. Uh, uh, tagging prompt dot invoke input with this. LLM dot invoke from. I don't get this. I'm not getting this. Okay, I am getting this. Uh, okay, okay, okay. So there's a way. I'm not really interested in getting structure outputs as of now. I already know they can do it, so okay, makes sense. Not gonna read this. What else? Extraction extracts structured data from text and other structured data using. Yes, okay, so this sounds kind of interesting if I needed some kind of extraction layer. Schema, okay, so again, you define a schema. So we have what is Pydantic actually? I really need to know. Pydantic, Pydantic is the most widely used data validation. Okay, so it's like SOD from TypeScript, but for okay, 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 why? Really? Okay. Why in the world would you create? Okay, I do know why. I do know why, so it makes sense. You have Python, you want to validate your types, but again, why are you using Python in the first place? Why didn't you start using uh, Go or some strongly typed language before? Why do you need to have a library to validate the types of your data? That doesn't make sense. your programming language, your code should explicitly or implicitly, not implicitly, it should explicitly tell you what type of data you get. Uh, This is okay, so I guess I'm gonna use this at some point. I wouldn't like to use it. I wouldn't like to have to use it. But again, same issue that it solves the same issue that sod from the like the sod library for TypeScript and library and for TypeScript and JavaScript applications solve. Okay, fast and extendable pedantic personality with linters. Okay, this. Okay, I think writing like a huge code base with Python and using Pydantic would be or will be a mess. And yes, yeah, no, yeah, no. Um, okay, yeah, I mean, it makes sense why Pydantic exists, but wouldn't like to have to use it. Okay, it's not like the worst thing, just not my doesn't fit like my standards, I guess, on programming language features. Uh, so I can define a schema. So I defined like a schema in Python code, a JSON schema in Python code. Okay, and I can extract data. System. Okay. Okay, so there's a way to extract like data. Okay, so there's a way to. Okay, so yeah, okay, makes sense. Would absolutely use this. Probably will use this because data extraction in a more structured way is nice. It's pretty nice. It's actually pretty nice. I just think that it would be nice to have like a LangChain ported to another language. For example, is there like a LangChain port to Go? Is there? Okay, there is LangChain port to Go. Please tell me it is like fully ported and it has all its features. I mean, how often does LangChain change? Because because I don't know. I wish I I didn't have to use lots of Python. But again, we're gonna do a first draft first, a POV, POC, whatever, MVP, MCP, first draft version of this MINA project. Then we're gonna migrate it to more performance optimized version of it. But for now, that's not the goal. Okay, so I really want to jump here because this is the most interesting part. I already covered like the basics of LangChain, and it sounds like the basic things about getting AI responses and RAG. Well, not RAG because we haven't seen RAG essentially, but getting about AI responses and loading data and I don't know like data extraction and basic Gen AI stuff is there, but I wanna get my hands more dirty and and start exploring more advanced like techniques that I could use launching for. So it says getting started with LangGraph to assemble LangChain components. Okay, so chatbots. Build a chatbot that incorporates memory. Okay, this tutorial is used with this abstraction. You can access that version of the documentation here. As of 0.3 of LangChain, we recommend using uh, LangGraph persistence to incorporate memory. Okay, tell me LangGraph persistence is open source, please. LangGraph it has a built-in. Okay, I'm gonna. Okay, I got blindsided. Let me turn this into dark mode. Yes, right now. Okay, yes. Okay, so LangGraph has a built-in previously implemented through checkpointers. When you compile a graph with a checkpointer, the checkpointer saves a checkpoint of the graph state and the superset. Okay, so you have threads, checkpoints. I don't need to read this, not now. Let me just do a quick research and get to know if is LangGraph free. Is it free? Yes, is MIT open source library. It's free to use. LangGraph. Okay. Okay. So self-hosted. Uh, LangGraph. Okay. Okay. So yes, if it's all self-hosted, I can use whatever library and I can use whatever library I want. Then it's okay with me. But if I'm going to get locked in by using some vendor third-party service, that's a no-go. So if your code is already relying on runnable with AHA or base chat message AHA, you do not need to make any change. We do not plan deprecating functionality in the near future. Okay. Okay, so chatbot. Chatbots are implemented with runnable with message history or were implemented, but now the recommended approach is using LangGraph memory. Okay, so yeah, just let me read this to check if this is simple. Okay, so we'll go over an example how to design, implement the LLM models. Okay. This chatbot will be able to have conversation with previous interaction with chatbot model. Now this chatbot will be okay. Okay, so there are several other related concepts you may be looking for. Agents. Yes, this is a very important thing that I'm looking for, how to build agents, which I'll be doing in a couple seconds. I first want to read this very quickly. Conversational RAG, enable chatbot conversation. Okay. Okay, setup. Okay, so you can set up this way and that way. You set up LangChain, LangSmith. It's optional. You get your model. You initialize it. Here, this guy initialized it with, well, this tutorial initialized with OpenAI. Then create a, okay, let's first use the model directly. Okay, so chat models. Okay, so a chat model are instances of runnables, which mean they expose standard interface for interacting with them. Okay, yes, easy to understand. So you simply call the model. We can pass, okay, a little message to invoke. Okay, okay. Okay, pretty easy to understand. Okay. We can, okay. I can even, okay. So it says, we can see that it doesn't take previous conversation, turn into text, and cannot answer the questions. Okay, this makes terrible chatbot experience. Yes, okay, yes. So what this tutorial is trying to tell us is that we should use X feature to get conversation history, so that it has enough context to remember like previous prompts and messages. So to get around this, we need to pass the entire conversation history into the model. Let's see what happens when we do that. Okay, so your name is, okay, what's your name? Refusal none. Okay. So this means that, and then we can see that we get, okay, so the idea here is that we need to pass like the previous messages to the model, so it knows like the conversation history, but that wouldn't be much practical because I don't want to be like pushing into a list like every message I've entered into a conversation to, so just so it can only remember like, just so it remembers like what I've told it. Doesn't make sense. So I'm guessing this LangChain library offers some kind of abstraction for it. It says The basic idea, this is the basic idea of underpinning a chatbot's ability to interact what? This is the basic idea underpinning a chatbot's ability to interact conversationally. So how do we best implement this? So it says LangGraph implements a built-in persistence layer, making it ideal for chat applications that support multiple conversation turns. Okay, so it makes sense, yes. Wrapping our chat model in a minimal LangGraph application allows us to automatically persist the message history. Uh, Wrapping our chat model in a minimal LangGraph application. Okay, so we're wrapping it under an application, simplifying the development of multi-turn conversation. LangGraph comes with a simple in-memory checkpointer, which we use below. See the documentation for detail, including how to use different persistent backends. Okay, first let me first check if this tutorial told us to set up some kind of LangGraph uh, like credentials. Because if it instructed us to set up a LangGraph credential, that would mean that this is some kind of cloud-based service, which we're trying to avoid. So as I see, there's no LangGraph credentials set. So, okay, I'm gonna give it a thumbs up for now. Uh, okay, define a new graph. So okay, you create a new graph workflow. Okay, so I'm guessing I would need to read about this graph thingy in the future, not now. Define the function that calls a model, call model that with a message and return messages dot response. Okay, so app equals workflow dot compile. Okay, so this subs that I've read LangChain's documentation on it, which I haven't. LangChain's not, but LangGraph's documentation, which is started to get confusing. LangChain, LangGraph, LangSmith, kind of confusing there. Okay, so yeah, it makes sense. There's a way to persist easily. Okay, so I'm gonna skim this because again, this is not an in-depth like tutorial. I'm not like trying to understand like everything now. I'm just trying to get like an idea of what I can do, and then I can get my hands dirty and jump back to documentation so I can uh, get to know what I really need to know when I need to know it. Not now, because I right now I don't need to know it. Let me jump to agents, because this is like the big part of why we're using like LangGraph, because we want to build an AI agent. We want to make an AI possible to call actions, to call tools, to call services, APIs, system calls, whatever. This is um, this is what we want. So yep. Okay, so it says by themselves, language models can't take actions. They just output text. A big use case for LangChain is creating agents. Agents are systems that use LLMs as reasoning agents to determine which actions to take and the inputs necessary to perform the action. It says after executing actions, the result can be feedback into the LLM to determine whether more actions are needed or whether it's okay to finish. This is often achieved via tool calling, which is what we're trying to achieve and what I'm really interested in how that works. I'm gonna read this. I want to read this. Does this explain how tool calling works? Because if it does, uh, it will help you understand like how tool calling works within LangChain. Because I'm guessing that each AI agent technology or framework or whatever exposes or creates or has its own methodology on how to tool call or call tools. In this tutorial, we will build an agent that can interact with a search engine. You will be able to ask this agent direct. questions, what should call the search tool, and have conversations with it. Okay, so this, okay, so this, okay, okay, so, hmm this makes sense because I think defining tools for both input and output, or for both reading and writing data, at least from the LLM's perspective, is the way to go. Because I don't know if like tool calling and a RAG system are like two different or are like exclusive to each other. Because if they aren't exclusive to each other, that would mean that I would have to implement like doubly, or like not doubly, but like double code logic for data retrieval, and like say like triggering an action. For example, let's say that I implement some kind of RAG system, or what I'm thinking is that the RAG retrieval or RAG system. Okay, what I'm thinking is that like the RAG tool calling or RAG is implemented within a tool. So for example, a tool, the same tool could in theory or can define like how to get input and um, no, how to write and read to data. For example, can a tool like define how to read data by, I don't know, exposing some kind of RAG call or RAG interface in the same way that it defines like way to write data by, I don't know, let's say the RAG system or the RAG tool or the tool itself is to interact with the file system. So could it define in the same tool like how to read from the file system and how to modify the file system? Because if that's the case, then there is some really interesting uh, features or problem spaces that we can address. Okay, so yep. Um, let me read about this. So it says the code snippet below represents a fully functional agent that uses LLM to decide which tools to use. It's equipped with a generic search tool. These 10 lines of code define that. Okay. It sounds like a bold statement, but I might just get my mouth shut up, probably. So it has conversational memory, meaning that it can be used as a multi-turn chatbot. Okay. In the rest of the guide, we will walk through the individual components that each part does. But if we want to just grab some code and get started, feel free to use this. Okay, that sounded like a really bold statement. Starting from the fact that half of the code is like 4 or 5 imports that aren't even like logic. But again, everything. The idea is, I mean, that's why people use Python, having everything as a tool or as a function call from an external library. Just import everything, and I don't know, call your functions. So, okay, let me just try to figure out what this snippet of code does. Okay, so it creates something called a memory saver. It gets Anthropic. It uses a chatbot. I mean, I think it uses Claude from Anthropic. Then it creates a search tool, tably search results, defines an array of tools, and it defines an agent executor, which creates a React agent with models, tools, and checkpointers. Okay, use the agent step in agent executor. Okay, uh, you know, okay, then use the agent. You just configure some kind of, okay, you create a configuration, which defines a map between a configurable and a thread. Then you loop in the agent executor stream, and what does that do? Okay, then it create messages. Okay, okay. I am I'm human message. Okay, human message. Hi, I'm Bob, and I live in San Francisco. Hello, Bob. You didn't ask. I didn't. Okay, okay. Okay, so to get current weather from your location in San Francisco, I can use the. Okay, so this is cool because I just noticed that it uses Claude. This in this case, this snippet of code is using Claude. Sorry, not the code. Using Claude, which is Anthropic's AI, which, as we learned from the one of the first streams, Claude uses the MCP protocol. So again, this LangChain library is kind of being like it's kind of being like let's say how can we call this, like LangChain here is being like an orchestrator or like a translator between APIs and protocols, because now I don't need to define like the MCP some kind of MCP client and server to interact with Claude or to make Claude be able to call tools. Now I can just use LangChain's agents, and that's it. Okay, and I get like the reasoning and the tool calls here. I get a response. Uh, I mean, and then I have this breakdown of each of the components. Model with tools. It's model. Okay, next learn how to use large language model to call tools. LangChain supports many different language models that you can use to intentionally select. And okay, so I can make my own agents, or I can use like this default agent used in this case. As I can see, create React agent with model tools and checkpointer, which what I'm guessing is that this create React agent does all of this under the hood. Uh-huh. It's what I'm guessing it does. Okay. So I can create this, and you can collage by passing a list of messages. By default, the response it's a content string. We can now see what it is like to enable this model to do tool calling. In order to enable that, we can use bind tools to give the language model knowledge of these tools. Okay, okay, interesting, very, very interesting. And since we can now call the model, let's first call it with a normal message and see how it responds. We can look at both the content field as well as the tool calls. So the first, okay, so I get none. What's the weather in San Francisco? Travelly, so I get the name of the tool. So each tool call is it's an object. No, it's not an object, it's a map. It's an array of, it's an array. Tool calls name, args, query ID. Okay, this isn't calling the tool yet. It's just telling us in order that actually call it will. Okay, create the agent. Now that we have defined the tools and the LLM, we can create the agent. We will be using LangGraph to construct the agent. Currently we're using a high level interface to construct the agent, but the nice thing about LangGraph is that the high level interface which is backed by a low level highly controllable API in case you want to modify the agent logic. Now we can initialize the agent with the LM and the tools. Okay, so okay. Note that we're passing the model, not model with tools. This because create React agent will call bind tools. Okay, okay, we can run the agent with a few queries. These okay, so this LangChain makes it really easy to create agents, which is impressive. Actually impressive. It says uh, we now run the agent with few queries. Now that for now, okay, these are all stateless queries. You will remember previous interactions. Now that the agent will return the final state at the end of the interaction, which includes any inputs. Okay, whatever. Okay, yes. Okay, in order to see exactly what's happening, Langsmith, I don't know. Okay, okay. And let's try now something that would invoke the tool and response messages. A message, tool message. Okay, okay. Streamed messages. I can also stream messages instead of invoking them directly, which is kind of useful. Streaming tokens. I can also stream tokens. Okay, adding memory. Then I can configure a memory saver, the check pointer. Okay, these. Okay, okay. So this technology makes it really simple. Okay, what I want to know is how does this happen? How do they like do all this like logic to translate between or to differentiate between prompts and commands to call tools? So let me take a look here. It says many AI applications interact directly with humans. In these cases, it's appropriate for models to respond in natural language. But what about cases where we want the model to also interact directly with systems, such as databases or an API? These systems often have particular input schema. For example, APIs frequently have the required payload structure. This motivates the concept of tool calling. You can use tool calling to request model responses that match a particular schema. Uh, okay, okay, it says you will call this, okay, you will hear this like function calling, although we use the term interchangeably. So it says tool creation. Use a tool decorator to create a tool. A tool is an association between a function and its schema. Okay, okay, so it basically explains how to create a tools, but what I'm seeing here, how am I hearing? Okay, okay, what I'm seeing here is that this is basically telling us like how to create tools. I see how this could be useful in the future because we're probably not going to be using like already created like tools because MINA is going to interact with different systems, with many systems. The idea of MINA is to be fully integrated with your full like internet, like not persona, but internet ecosystem, your personal internet ecosystem. Let's call it that way. So it's going to be calling many tools. I do really want to know how does this work. So let me read this quickly. It says use the add tool decorator to create a tool. A tool is an association between a function and its schema. Tool, okay, then you have tool bindings. The tool needs to be connected to a model that supports tool calling. This gives the model awareness of the tool and the associated input schema required by the tool. Then tool calling, when appropriate, the model can decide to call the tool and ensure its response conforms to the tool's input schema.
So I'm guessing that the tool calling, like that NLP logic that
like the determination of when to call a tool or when to not call a tool depends a lot on the model because although you can bind a model to that tool, let's say, to a set of tools, each one has its way of determining when to call like a tool. For example, Anthropic's Claude has MCP, OpenAI has its like OpenAI functions. Then well, I don't know what Llama models use. Or are they even capable of like function calling? Not sure. So yes, so you have tool creation, tool model, tool calling, which the tool calling logic is done by the tool itself. So it says this article illustrates the recommended workflow for using tool calling. Created tools are passed into bind tools method, which isn't like necessarily a thing we must call because if you create like agents directly within like LangChain agents, then you only pass like the model, the memory, or the checkpoint things, and the like the set of tools. So yeah, okay. This model can be called as usual. If a tool call is made, model's response will contain the tool call arguments. The tool call arguments can be passed directly to a tool. So it says this is like the tool. Okay, so this is like the tool recommended usage. You have tools, models with tools, then response model with, okay, models put bind tools and model with tools to invoke tool creation. Okay, the recommended way to create a tool is by using the tool decorator, which is basically a function. Okay, tool binding. Okay, it's very easy to bind tools. Tool calling model, LLM with models, bind tools. Okay, natural. Okay. So a key principle of tool calling is that model decides when to use the tool based on the input's relevance. Okay, the model doesn't always need to call a tool. For example, given an unrelated input, the model would not call the tool. Hello world. You know, this tool calling logic, whatever thing, however you wanna describe it, is probably much better than the approach that I had initially, where I would have like an orchestration layer to do this to do like that tool calling functionality or to determine when to call a tool programmatically. Yes, that was an approach, but it wasn't like an agentic approach. Like an agentic AI approach was more like an AI assistant approach because it required more like human logic, not human logic, but like writable, not writable, but more like let's call it like how can I call it? It required more like code logic instead of unpredictable, like the unpredictability that like these models have. Okay, I'm thinking out loud, so I might be saying things that don't make much sense technically. But yes, uh, what I'm trying to say is that like tool calling and agentic models that are able to determine when to call tools are a better approach than having to determine like when to call tools like using some kind of NLP orchestration layer would be dumb. Not dumb, but uh, less effective, less intelligent. Tool implements a runnable interface, which means that they can be invoked. Example, okay. LangGraph offers pre-built components like tool node that will often invoke the tool on behalf of the user. Okay. When designing tools to be used by a model, it's important to keep in mind that models have explicit tool calling APIs will be better at tool calling than non-fine-tuned models.
Okay, so yeah, makes sense. Yeah, so I should probably define what I should probably assess or choose a tool calling like capable model when defining like what model will MINA use for its core AI layer. Then model will perform better if the tools have been well chosen names and descriptions. Again, makes sense. Simply narrowly scoped tools are easier for models to use than complex tools. Asking the model to select from a large list of tools poses challenges for the tool. Asking the model to select from a large list of tools poses challenges for the model. Is it right? Is it always right? I mean, does that mean that I can train like the model specifically like to does it okay, so the number of tools that I attach or that I bind to a model increases or decreases its effectiveness to call a specific tool. So is there a way to train my model to understand what specific tools to call? Or would it be better to have different models or different models for each like set of tools? Um, not sure. Not sure what it's the best fit here. Langgraph, don't want to read about this now. Um, yeah, okay, not also not want to read this. Conceptual guide. Okay, this is interesting. Uh, okay, you know, okay, so we read quite a lot of stuff. We've read about tons of stuff. This guy introduced drag and word through minimal implementation, load, split, embed, store, quest, retrieve, prompt, and let. Okay, I do know how RAG works, at least from a high level flow perspective. Don't need to read this. I already know what the capabilities of this. Okay, data source, summarize text. Okay, I want to read this. I want to read this. I want to ignore. Okay, this how-to guides. Okay. I want to keep this here and to close this. Wait, what was this? Dogs together. Okay, I want to keep this here. Keep this here. Read this quickly. And this tutorials thing, I think I can close it. Just want to read this final thing, and then we gonna jump to some conclusion making and define next steps. Cause yep. Okay, so in the tutorial, that is tutorial demonstrate text summarization using building chains and line graphs. Okay, in previous versions, okay. So suppose you have sets of documents, Notion pages, customer questions, etc. You want to summarize the context. LLMs are a great tool for summarizing. Okay, yes. In the context of RAG, summarizing text can help distill information in large number of retrieved documents to provide context for an LLM. Yes. Okay. In this workshop, we'll go through how to summarize content from multiple documents using LLMs. So, using language models, using document loaders, web-based loader to load content from an HTML web page. Okay. MapReduce for large set of document stuff. Uh, okay, I've read enough. I think I've read enough theory
I want to get my hands working on something. Get my hands somehow dirty. Start experimenting, getting some actual error responses from functions, getting my feet wet. But I don't know what are our next steps. So let me just visualize what we have by let me visualize what we have by visiting our features thing. Okay, so we determined that we want an agentic AI solution, right? We've determined what kind of technologies we need. We've determined we've determined some stuff, but again, I I think we should set or determine one last thing, or not last thing, but the next things. Because I've been doing some research now, uh, quite some research now, been learning tons of new stuff. Uh, Still not convinced, or still don't want to use like Python again. But again, sometimes you probably shouldn't use what you want to use, and should use what you should use. It's a thing I've heard from some guy in the internet. Maybe. Or I just came up with it on the spot. Maybe. Who knows? Anyways, what I'm trying to do right now is I'm trying to determine what I'm gonna do. What will I be doing? Now, like right now, I wanna stop stream because we've worked for almost 3 hours now. How much? 2 hours and 57 minutes. Yep. It's been almost 3 hours. Don't wanna burn out myself. I don't think I will burn out working 3 hours on a project daily. But it's 9 p.m. Usually go to sleep at 10 p.m., 10:30. So that means if I stop now, I get some time off to do some leisure activities, meaning nothing productive mostly. Uh, Anyways, what I'm trying to what I'm trying to do right now is that I want to determine what I'm do next. In the short term, I want to stream and let all the thoughts sink in, all the learning things or all the things that we learned today sink into my brain. I'm going to sleep on everything that we learned today. Get all those concepts around my head. um, s- through the stream I came up with some ideas that I didn't mention because I need to assess them first. Need to sleep on them to to assess if they're even worth mentioning. Uh, so yep, that's a short-term goals as of now, and for mid to long-term goals, uh, at least regarding to the project, or to this whole development thing. I want to start getting my hands dirty, start calling functions, start using actually like coding stuff because um, although research is a big part of this project because we're learning new tech, it's a new problem space, at least to me, in partially a new problem space. Uh, I really want to get myself doing some more uh, stuff with my hands. So yep, really, and we did some research on LangChain. We did some research on LangChain's capabilities. Uh, what we did actually in the last stream is couple streams maybe is something that I usually do when I'm just trying to assess a new technology or like trying out a new technology is that I don't want to get my hands directly like in the first approach to it. I don't like to get my hands dirty like on the first try because I like to first understand like what are the capabilities of the thing that I'm going to tackle. Like what are the capabilities of the thing I'm going to use. I don't want to know all the whole details, but I would like to know, or what I usually like to know, like what are the available features, and then I can get my hands dirty and like use the actual technology that I just read about. In that sense, or doing that not allows me to explore a technology knowing what are my limitations, or not knowing what are my limitations, but knowing like at least like the minimum, very like the bare minimum features that the technology provides. So that I have like a baseline for what my expectations when exploring the tool are. And then when I'm actually like exploring the tool like more pragmatically, like actually delving into the inner workings of the tool, in this case LangChain, I know like I get to know like by myself like what are the actual limitations, like the top limitations. Because in the first phase I knew what were like the bottom limitations, like the bottom baseline of what the tool can do. And then the second phase of like the exploration is determining what's like the top limitations. That's what like the top line of where or what the tool can do. So that's what I want to do on next stream. We're gonna get our hands dirty. We're not going to create directly like we're gonna try to create like a first draft of MINA using LangChain, and there are two pathways that we're gonna potentially achieve. Either LangChain fits our needs, and we continue using LangChain to develop a more let's say a more solid version of MINA, or I can simply discard LangChain and we've lost nothing. We've only we've lost nothing, even the opposite of lost something. We've learned something because we would have learned how LangChain works, and I could use those skills in future projects or in future versions of MINA even, or in future iterations of any other kind of project. So again, that's it, right? So we haven't or we aren't going to lose or not. We're gonna take advantage of Mina on this whole exploration phase before coding or programming the first draft of Mina. Because yes, yeah, I think this kind of exploration, uh, kind of reading documentation and then getting my hands dirty with the technology is like a good approach to exploring new tech. Because I already explained why, but that's my idea. So yeah, um, it's 9:15 on my time zone right now. So yeah, uh, just what I said. Summarizing today's stream, what we've done, what's in progress, and what's our next steps. Okay, so what we've done now is that we've done quite some research. We've done some research. We learned about AI models. We learned about the format of AI models. We've learned about like how to load models. We've learned about how to download local models. We learned about that not all models can be run locally on your machine because proprietary and whatever other um, business or enterprise proprietary stuff things. We also learned about vectors towards RAG. We've delved deeper onto RAG. already knew about RAG and the basic usage of RAG and connecting RAG systems to LLM models, but never knew like the whole inner workings of RAG. I don't know how the inner workings of RAG now, but I do know more about RAG than I knew like yesterday, probably. We've about talking about RAG. We've also learned about how you use different embedding. You use like different models to create embeddings. Like to do embeddings to embed text into vectors, which are then stored in vector stores, which are then used to provide feedback to our LLM. Feedback, not but extra context, not feedback. So yeah, we've also learned about LangChain's, LangChain's ecosystem, LangChain's LangGraph, how RAG, how to implement agentic models, how tools, how it provides like an unified interface to interacting with many LLMs, and yep. So yeah, we've learned enough to get our hands dirty and to know at least what we can expect, like at the minimum from LangChain. So yeah, tomorrow, it's Monday, okay, Tuesday. Tomorrow is Tuesday. I was checking out my calendar. I know what I, why I didn't realize my calendar was just there. Yep. Anyways, tomorrow we're gonna get our hands dirty. Finally, after like 5, 6 streams, we're gonna get our hands dirty. And yeah, explore, try and error, maybe even discard or approve the final usage of LangChain, and that's it. So yeah, I think I'm rambling now because I'm repeating myself. Uh, some I'm repeating myself. Yep. So yeah, but I think I spent like 7 minutes rambling and saying the same thing again and again. So what I'm gonna do right now is I'm gonna add this whatever we uh, added to our GitHub repo, and I'm just gonna core a layer TDD questions. I'm just gonna commit this to our public cloud repo, cloud repo, GitHub repo, so you guys can have it. But there's not much yet because no coding has been done yet. But anyways, I'm gonna leave it till here because it's late. And yep, expect me tomorrow exploring, not exploring, but actually getting my hands wet, getting my hands wet, not but getting my feet wet with LangChain. Now that we have understood how LangChain works, so that's bye bye for today, and probably see you tomorrow. So bye bye, ciao, adios, buenas noches, ciao, bye bye. Thanks for joining, and